you start where this bond is, because this bond in N- convention has to go from the carboxylic end to the methyl end. So, everybody agrees that there's 7. Everybody agrees that there's one double bond.
Yes.
So this N represents 7, okay? This -3 represents how many you count back to start the first double bond, and I'll just abbreviate that as our equal sign. To start the first double bond going toward the methyl end.
This is delta, is that what you said?
No, this is N-, the IUPAC.
Oh.
So, we have 7 carbons in the molecule. There's one double bond. The first double bond occurs at going in this direction. So on the top, and I'll write that this is N- number, okay? Going in this direction, we count back 1, 2, 3.
I'm confused.
Yeah, I'm so confused right now.
What?
What? Why don't we count from the methyl carbon
Yeah,
then?
shouldn't you just count from the methyl group to the where?
Okay,
the
so
bond-
that's omega.
What?
You're
No, I
not,
mean,
but you're counting from
carboxylic.
the right?
Wait, okay.
Carboxylic acid.
Right, yeah, so I counted all the way to the end, right? I
Yeah.
counted from 1, 2, 3, 4, 5, 6, 7.
Okay.
Okay, everybody's good with me there?
Yeah.
Yes.
I counted with this double bond. There's
Yes.
one double bond.
Yes.
So, let me put omega up so you can see the difference, and then it'll make more sense. Okay? So this is omega, all right? Okay, so this also counts in this direction, right? Right? Because this is our alpha carbon. Question.
Doesn't the IUPAC number 1 at the methyl end? And then goes left to the,
Okay, so
it doesn't count from the right, it counts from the left.
they both count. So delta, okay, there are 2 parts to the IUPAC. The delta part, numbers in that direction. This part, if you're using the N- part, in order to understand the minus part, still counts in that direction. Like the N-, like when they don't, you notice they never write N, right? They always write N-. And the way to get N- is to count all the carbons. You can count them in either direction you want, ultimately, right? You can count them in the direction that you're talking about, right?
Right, but then you go from that end.
So you
1,
can,
2,
and you
3.
can go in this direction.
Right.
But if you use, but the minus part, right? So the difference is in the direction of this bond. If you count in your direction, or if you count in my direction, either way, you have to make sure that you're numbering the bond in this direction. So let's do omega. Okay, so this is omega. All right, so you count 1, 2, 3, 4, 5, 6, 7. Right?
Mm-hmm.
There's still 7, right? Omega, 7. So there's 7.1. And where's the double bond? So 1, 2. So this is where it gets confusing. It's 1, 2, 3.
Wait,
Right? 1, 2, 3.
Last week you had mentioned that it's the opposite way.
Right.
This is
The counting the bond. You're counting the bond in the opposite direction.
No, I mean like
Carboxyl. Yeah. Okay. So you can count it any direction you want. In other words, to get this number, whether you count in this direction or that direction doesn't matter. Right?
But it does matter where you find the double bond and which direction you count.
Right. Yes and no.
wait, what?
Okay. Okay. Hang
Take a
on.
deep breath.
Okay. So when you can count from either end. The reason that I'm counting from this end in both directions, there are 2 reasons that I'm counting from both directions, in this end from both directions. One is the minus, okay? And the other one is to highlight the direction of the bond. So you have N, right? We have N molecules in the molecule no matter what, right? Okay, so let me show you here. There are 2 ways to do